we'll encounter. Um, if we know secant of theta is square root of 29 over 5, that's some information, but we also need to know what quadrant it's lying in. Once we know that, we can kind of figure out everything else. So we have to set this up. We need to know what quadrant it's in. Otherwise, all of our answers, they're going to be off. So let's just see what this looks like. We're going to have quadrant 4. I don't really know, how where this point's going to end up. So let's just arbitrarily say it's right there. I know it's in quadrant 4. That's all that really matters. And then we can label these side lengths. So I don't know which sides the square root of 29 is and 5 is, but I do know that secant is related to cosine. So I could flip this around. This would be 5 over square root of 29. And then I know what side length. So this is adjacent over hypotenuse. So theta being right there is adjacent has 5, hypotenuse has square root of 29. We could use Pythagoras theorem a little backwards this time to figure out this side. So up here I'm going to say this is 5 squared. I'll call the thing at the missing side y because it's in the y direction. It doesn't matter what you call it. This is square root of 29 and then squared. So this is nice because the square root and the square cancel each other out. We get 29. This would be 25 plus y squared. Doing some basic algebra solving. If you get 25 out of there to the other side, because we're solving for y squared. And this is y squared is 4. So y is 2. Okay. We know that this side is, oh, not 5, it's 2. So this is 2. We have everything we need to figure out all the rest of them now. So this is going to be secant and cosine. So we need sine of theta, tangent of theta, cosecant of theta, and cotangent. Okay. Sine is opposite over hypotenuse, so this is 2 and root 29. I'll fix both of these ones in a second because we have a square root on the bottom. Tangent is opposite over adjacent, so that's 2/5. I can find both of these really quickly as well because they're just reciprocals. This is 5 over 2. This is square root 29 over 2. That's 29. Just to quickly fix the other two that have the radicals on the bottom, that's just going to be, you multiply it by, we've done this a few times now, multiplying it by square root 29 over square root 29, and you end up with 5 root 29 over regular 29. And that's what cosine of theta is. Sine, we know what we're going to end up with. It's the same deal. This thing just comes at the top. It's 2 root 29, and then the bottom becomes non-radicalized. So 29. Okay, so I'll have another example here. We have cosecant in quadrant 2 with this thing. You can start by drawing a triangle. We know that at quadrant 2 is going to be some point over here. I know that this is the triangle that's going to be created, and theta is there. But I don't know what the sides are, though. So we have to think of cosecant as being, it's related to sine theta. And then it's its flip. And we can fill that in. So sine is opposite over hypotenuse. So this is 9 over square root 85. Then we want to figure out what this side is. So we can do that next. Then we would figure out this other side. That's just going to be 9 squared plus, in this case, I don't have the x direction, so I'm going to call that x squared is square root of 85. And that's 9 squared is 81. You're going to subtract to the other side. 85 it's supposed to be squared. 85 squared, square root of 85 squared is going to be 85. And then when you subtract 81, you're going to get 4. So essentially this is 4, x is 2. So we know that side's 2. Then we can find all of the other trig functions. So we have cosecant and sine. We need cosine. We need tangent. And then we need those guys, inverse. So this is secant, theta. This is cotangent. Cosine is adjacent over hypotenuse, so this is 2 over root 85. And then I can flip this and get secant right away. So root 85 over 2. However, I got to flip this guy. I got to rationalize the denominator. You're going to end up with 2 square roots of 85 over 85. Tangent's nice, there's no roots, so opposite over adjacent is 9 over 2. And cotangent is just the inverse of that, or the reciprocal of that. So 2/9. All right, hope the video helped.